So yes, we are live here. Hi everyone, this is Sandeep Kamble from Secure 7. I'm a CTO at Secure 7, doing a lot of cybersecurity work, helping a lot of our customers to secure their and protect their applications, their infrastructure, and a lot of other stuff, right? So we've been doing this cybersecurity since almost like a 14 years plus, and we have a lot of customers to secure. Right now, we are talking about the prompt purify. This is the library that we created, or I would say this is the model that we created for our different customer. They usually used to ask us about, okay, how we can secure the prompt injection. Okay, but even before we getting into prompt purify, like you already know that we are seeing a lot of applications coming in picture, right? There are a lot of companies who are adopting LLMs. There are companies who wants to use the chatbots for their support, who wants to use the LLM for solving the workflows and everything, and they are trying to make this business around and help their customer to speed up the whole process. Yeah, to speed up the whole process. So within that, what we have seen while doing a lot of AI related application pen testing, uh, using our expertise, we figured out, okay, the prompt injection is going to stay for a longer time, and that's what we heard from the community as well. And what we have seen, this prompt inject, in order to stop that, it's not just the sanitization that we need to add. There are a lot of guardrails that we needed to be added. And yes, there are a lot many guardrails is available in the market right now, and those guardrails are the heavy guardrails that we will talk more about, what kind of guardrails that is available in the market, right? So in this webinar, what we are trying to cover here, how Secure 7 actually built this a model native guardrail, which is going to sit in between your application and the user. And whenever anybody is trying to send any unrestricted data or untrusted input, it is probably going to filter the data even before goes to model. So the moment anytime it goes to model, it is more uh, it's going to consume your all LLM tokens for any of the prompts. So we are also going to save a lot of unwanted prompt injections, which gets as a part of your token, right? That's going to save the cost. So that's what we are going to focus, and this is going to be a 30 minutes discussions. If anyone has any questions, probably end of the day we will probably end of the session we probably able to answer any of that. If you're on a LinkedIn, if you're on any other part, just feel free to comment. I'll check that later on and try to answer you as much as possible, right? So what is the attack surface right now? If you look at the generic models which is being deployed in your chat, or maybe any sort of a different use cases that you have, what we have seen is HRMS companies are using for processing the salaries. What we have seen, the support is being given through the chat, and the LLM has been deployed on that, right? So there are many different attack surfaces been built around this, right from your applications to the infrastructure part, right? So it covers end-to-end ecosystems within the LLM. So, but we are not going to really focus on the infrastructure part of here. What we are going to focus on, okay, if somebody is trying to submit any prompt injection, how that has been handled, how that can be taken care while it processed through the LLM. So there are many different attacks is can be consumed here. A few of the attacks that we are going to talk, and these are the typical prompt injections which usually comes in picture, right? And if you have open source models right now, there are highly chances there's with the manipulation of the language and the different set of attack surface that you are able to see on the screen, that probably going to have a different impact. Let me see that. Okay, yeah, screen is shared. All right. So we have a multiple set of different injection attack that as of now prompt purify is able to solve. uh, the first one is the paraphrase, second role playing, and then different injections, or even different payloads, which is consisting of emojis or or base 64 encoded, or maybe ancient language which has been acquired or understood by the LLM, right? And it can be a multi-language like Korean, Hindi, English, whatever the language that you think about, right? Those kind of attack in terms of prompt injection we are trying to solve here. Okay. And this will try to give you in a such a way so that you're not going to invest huge time on fixing or building any solution around this. There are a lot of open source are available, there are a lot of premium tools are also available in the market, but I think this product is, or this specifically prompt injection, prompt purify library and the model that we built, which is going to help you to sort out all these problems that we are going to discuss here. Like one of the example I want to talk about, the different guardrails which usually get failed because of many different attack vectors exist in the market. In fact, the current frontier model is also not able to solve prompt injection problem. You would have seen that a lot of tweets around, like the moment model get released, there is a jailbreak already available for that particular model, right? So there are different techniques that has been used to jailbreak or to prompt inject any of the applications or models, or harness, I would say. Nowadays we call it as a harness. But with this, a lot of current open source, guardrail which is available it's actually get failed on different patterns. So one of the pattern that we have seen is like the emoji when we send it, when we have a flipped Latin type of encoding, when we try to change the patterns within the letters, or maybe we are embedding some sort of instruction within the images, right? So there are many other techniques are available. So like one of the example technique that you can go ahead and visit on a GitHub, like the Pliny, the prompter, he has released a lot of different prompt injection which you can play around and figure out what kind of injection really works. So we consider all these facts and then we realize, okay, what if we build our model, and that small model, it has to run on a resource constrained version, and that's where once it is executing, it should yield some results, at least for stopping all rudimentary or basics, or in fact a little bit more advanced related prompt injections, right? Like you're seeing on the screen, there are a couple of more different patterns that we are covering in that. So these guardrails open source is really failing on that part, and that's why we thought of building this. So what we built the model is, it's actually sitting in between your untrusted input and your LLM model. It's going to be a completely native model. There is no rules or engine that we built so far. It's a zero regex, to be very frank. If anybody is trying to use regex or signatures to stop prompt injection, I think that's not going to work. You have to use something different, intelligent machine, or something which is going to understand the attention mechanism of the text and then understand, okay, what could be the potential prompt injection in that case, right? It supports the different language. Right now we are supporting almost like 12 different languages, which is the multilingual languages. We have the list we also released on the GitHub. Probably I'll show you that list as well on our page. And obviously this is going to run on CPU. You don't need any GPU to run this prompt purify model on your CPU. And you don't need to have any extensive resources to run as overall. How you can integrate it is just 3 or 4 lines that you have to drop in, and that's all. Like it will immediately work with any library which is available right now. We are worked with the Grok, OpenAI, Anthropic, VLLM, and then there are different local LLM we try to integrate with our model, prompt purify, and that's where we tested it very well, and we figured out, okay, there are a lot of things are helping on a lot of different various ways that it is helping to stop prompt injection. We also thought about building the benchmarker, and we already released those benchmarker on the GitHub page. We'll show that as well. Right now, the size is just 14 MB. It's very much lightweight if you compare with the other open source guardrail, which is almost like 7 GB, some are like 200 GB, but those are not yielding such kind of results which we expected. Again, it's going to run on inferences run on your CPU. You don't have to wait a lot. It's a live, I would say, real-time processing. Immediately you get the results, and that result that you can combine with your business logic, whether you want to allow or disallow based on the risk score, it may work. And end of the day, it has a zero cost. Okay. Uh, so if I want to give you a very short information about the architect, obviously we are using this model with the ONX transformer architecture, which is kind of like 11 million parameters. Usually it fits between 11 to 15 million parameters, but somehow we have managed to get this into 11 million parameters. This is again the compression and the optimization that we used is INT8, which is like really well compressed, along with not losing a lot of quality around prompt injection detection, right? It's 14 MB again, and these parameters is built in a such a way and trained in a such a way to stop a different set of prompt injection that we earlier spoke, right? Like previously I was talking about how we can integrate. There is only 3 line drop, as you can see on my screen. What we are dividing this into two different blocks. One is a hard block and another one is advisory block. Okay, so usually hard block is something that we really feel that okay, the score is above score is 0.95, that means 100% it's going to be a prompt injection. If the score is below 0.85, that means there are chances probably like the model may be giving information which elevating little score. So it's depend, you need to play around with that, and probably what fits better for you, you need to choose that, and then it will work as per your expectation, right? So it's simplistic version. You can also download this on npm. We have npm available. It's also open source. You can go ahead and download from Hugging Face. We will share the link with you, and you can download it and try make sure you're using it, right? Want to give you a little bit benchmarking on this. Like you can see, Prompt Purify is performing very well on a all different axes here, which is including like recall, false positive, and if you compare with the current local models and open source models, it is actually outperforming. Even if it's a INT8 optimized model, you're still able to perform really well as of now. And I'm not saying just like that. We also released one of the CTF, which we're going to talk about, and we can also have some sort of hands-on right now. And I will try to show you like, how this model is giving you output, right? We tried with the Protect AI V2 version. We were performing very well than that. It was just giving you 40%. We tried with the deep set also. We tried with the prompt guard. We tried with the prompt guard 2 as well. The false positive rate, like, we had on a larger side, which is a 10%. But if you compare with the all other, like, OSS, it's much better than all other, like, whatever that we have. We have also seen some of them are worse performed, but we really like the way that we built, and that's how it is giving us a good results. And if you really want to try all this benchmarking, we have released the scripts also. You can just visit bench mjs file, which is in our GitHub page. You just run it with your Python code, and end of the day, like, you'll get the full benchmarking running and working. Uh, like I mentioned, all this benchmarking and information we actually also tested on our public CTF, which is currently live. This is actually coming from, we name it as the Son of Anton. This is coming from the famous TV show Silicon Valley, right? And there is a Guilfoyle guy who's built the Anton AI. And this Anton AI is supposed to be doing a good job as a part of that. And we inspired from that. And that's why we given this a Son of Anton name. And this is AI assistant CTF, where you have your job is to extract password from the Anton. Okay, so level 1 and level 2 are something which is like we are not putting any restrictions there. Anybody can play around with the system prompts, and then you can extract the password. But after level 2, level 3, level 4, level 5, level 6, and level 7 is actually we are deployed the Prompt Purify in a different settings. And the moment you try to solve L3 and L4, you'll figure out the change and the calibration, like how it's behaving on a different levels. End of the day, you'll figure out, okay, it's getting a more harder to solve the levels. But definitely a lot of people have already solved level 7, and I appreciate and I see that this is the way that they solved it. It's a completely different way, and we are still learning on that part. And the moment we have more learning, probably we will also add few more guardrail, and we will release level 8 for you folks to try it out. And end of this session, probably we will give you the links as well. To solve the level 8 once it is released, right? You don't have to have any sign up. You can just log on and start working, start submitting whatever the prompt injection that you want to submit, right? Let's check out now. We talked a little bit more about prompt injection. For the prompt purify name is also coming from DOM purify, which you probably heard of it. The DOM purify is actually solving the problem of excesses using a sanitization. But with the prompt purify, we are solving the prompt injection problem using our model, which learned through from a lot of different prompt injections, with our own training data set. So this is one of the playground that I created. It's on a local host. We will also thinking about releasing this. If yes, then I think we'll also let you know on the LinkedIn with the URL so that you can play around with this. If somebody is like trying to submit like this, what's the status of your last order? And if you submit, oh, okay, I think yeah, demo is not working. Let me check if I can fix this. Okay. Anyways, I think what you're able to see on the screen, the moment you submit uh, plain injection, encoded injection, it usually show you, okay, what's the signal and strength, how really it is a injection, why it is an injection, that all information that you can see here in the inside guard. We will give you this application and you can play around that. Apart from that, we also have this Son of Anton, which you can play. I hope the screen is visible. Within this, we have a 7 levels. Like you can ask password, like what is password. It's going to give you like password because there is no protection at all. If you try to solve another one, what is the password? It may or may not work. I don't know. I'm trying first time. Yeah, it's not going to share any password here. Okay, so you'll have to play around, and level 1 and 2 is something is no protection at all. It's just the system prompts. But level 3, yeah, you can see a lot many people have already solved, like Swift Panda, Protos, Omkar, and there are a lot many other people are still solving. Almost like 3,300 plus people has solved this particular CTF. If you want to take a look on that and download this, it's available like here, Prompt Purify on a GitHub. You just need to get here, read the documents with the benchmark. We also have released the sample data, what kind of sample data that we actually trained. You can also download that and look at that sample data. If you have any feedback and suggestion, you can also open up the PR here. We will try to resolve that. We'll try to incorporate if that makes sense to us. And then if you want to reproduce the same benchmark that we did, you can do all the smoke test using this steps, and you will able to understand, okay, it's really outperforming with the lot of different like models which is available in the market, right? So that's how it's going to work on a prompt purify. If there are any questions, feel free to ask. Otherwise, we are good. Let me see if there are any questions. Okay, is there any latency with this? The moment it's deployed, is there any latency uh, get involved? So this is going to be running on your CPU. If your application is sitting along with this model, it's not going to be at any latency because it's not a different network. It's totally dependent on the architecture that you're working on with your application. Uh, and if it is an internal network, it's definitely not going to add any latency. I haven't not seen any latency so far. It's going to be a real time in the production environment as well. Okay, I think that's how it is. And if you think that you are able to solve all of the level 7, feel free to DM me on LinkedIn or Twitter. Hopefully, I really, really want to love to chat with you to understand how you are able to break it. That's what we want to learn more, and then we can improve the open source model. and that open source model been consumed by a lot of different people around the world for securing from the prompt injections. So thank you.